Hi everybody, today we are going to start our last method of solving quadratics, which is using the quadratic formula. Before we do that, we're going to review how we can simplify radicals because we'll be doing that quite a bit today. So remember, when you simplify radicals, you think about a perfect square that goes into those radicals. And so our perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. And the square root of each of those are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So our job when we simplify a radical is to figure out what of all those top perfect squares, right? The perfect squares are up here along the top. Which one is the biggest that goes into our radical if it's not a perfect square itself? Like for example, this guy is a perfect square, so that's plus or minus 4. 50 is not a perfect square, so if we zoom out and find that 25 goes into 50 twice, so this is plus or minus 5, radical 2. 28, 4 goes into 28 7 times, so this is 2, radical 7. And then 72, 4 goes into 72, 9 goes into 72, 36, though, goes into 72 twice. So 6, radical 2. Okay, so that's just a review of simplifying radicals. Now the quadratic formula uses the a, b, and c values. Remember, a is always in front of x squared, b is always in front of just x, and c is the constant at the end. And so to solve, we do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So when we solve using the quadratic formula, first I have you guys figure out what are your a, b, and c values. For this equation, this quadratic, x squared plus 5x plus 4, it's equal to 0, so that's our first step. We want to set it equal to 0. Then we solve for a, b, and c. A is 1, because there's no number, but it is a 1 in front of x squared. B would be 5, and C is 4. So now I plug this into my calculator, or into the formula, sorry. X equals negative B, so negative 5, plus or minus, always that plus or minus because we're taking the square root, whoops, sorry everybody. B squared, so 5 squared minus 4 times A times C, all over top of 2a. Okay? Now I'll tell you that the first thing I do to simplify is figure out what number is under the radical. So that's 5 squared minus 4 times 1 times 4. So I'm going to open Desmos and do just that. 5 squared minus 4 times 1 times 4. Exactly as it appears, and that's 9. So now when I go back to my notes, I know that under that radical is a positive 9. Okay, and the square root of 9 is 3, so this is negative 5 plus or minus 3 over 2. So now I do this twice. X equals negative 5 plus 3 divided by 2, which would be negative 2 over 2, or negative 1. And then I do negative 5 minus 3 over 2, which is negative 8 over 2, or negative 4. Okay, I'm going to pick this up and scoot right there. Okay, for our next quadratic function, notice that it's not equal to 0 and our c value is over here on the right. So to move that over, we're going to subtract it. So I'll get 3x squared plus 8x minus 35 is 0. So now my a value is 3, b is 8, c is negative 35. So then the formula says x equals negative b plus or minus the square root of b squared minus 4ac, and you take the negative, not 6, the negative with it, all over 2a, and a is 3. Okay, so now I go to Desmos. 8 squared minus 4 times 3 times negative 35. So 8 squared minus 4 times 3 times negative 35 is 484. Ooh, that's a big number. So x equals negative 8 plus or minus the square root of 484 all over 6. Now, I don't personally know if 484 is a perfect square, so I'm going to go back to Desmos and see if I take the square root of 484, yep, 22. So now I have x equals negative 8 plus or minus 22 over 6. Okay, to solve this, I'm going to say x is negative 8 plus 22 over 6. Well, negative 8 plus 22 is 14. Is that right? Yep. Over 6, which is 7 over 3 if you want to simplify. Or x equals negative 8 minus 22 over 6 is negative 30 over 6, which is negative 5. Okay, awesome. Here, 10x squared minus 10x plus 5 equals 0. So we're set equal to 0. A is 10, B is negative 10, C is 5. Now this is a great example where B is negative. So in this example, remember the formula says x equals negative B, so negative negative 10 plus or minus the square root of B squared minus 4ac all over 2a. Okay, so now negative negative 10 is just positive 10 plus or minus, okay, negative 10 squared minus 4 times 10 times 5. So if I clear this out, I have negative 10 squared minus 4 times 10 times 5 is negative 100. Okay, so square root negative 100 all over 20. Now we know the square root of a negative will have an I. Okay, to make that positive, we write our I, and then the square root of 100 is 10 over 20. Okay, now in this case, we can write these separately. X is 10 plus 10I over 20, which can be simplified. All three numbers can be simplified by a factor of 10. So that would be 1 plus I over 2. Right, if I divide all three of those numbers by 10, I get 1 plus I over 2. And this would be minus 10I over 20 would be 1 minus I over 2. Okay, so sometimes when you solve the quadratic formula, you do get an I, and remember, we can't combine when we have I values, so that means we just leave them in our solution. Okay, in this last one, we've got our B term over here on the right-hand side, so we need to subtract that. So our equation here is x squared plus 64 minus 16x is 0, but remember B switches, with C, so it's in the middle. Okay, A here is 1, B, negative 16, C, 64. So in this case, x equals negative 16 plus or minus the square root of negative 16 squared minus 4ac all over 2a. Now, whoops, when I start to simplify this, I get positive 16 plus or minus the square root. Now I'm going to go into Desmos, negative 16 squared minus 4 times 1 times 64. So negative 16 squared minus 4 times 1 times 64 is 0. Oh. So 0 under our radical over 2. So then when I take the square root of 0, x equals 16 plus or minus 0 over 2. So if I add or subtract 0, I'm not going to get anything different than 16 on top. So this quadratic only has one answer, 16 over 2, which is 8. So in this case, we would have one x-intercept. It would just sit on the x-axis. We have one real solution. Back here, we had two imaginary solutions, so we would have no intercepts. Up here, x equals 7/3 and x equals negative 5 are two real numbers, so we would have two x-intercepts. And over here, same thing, negative 1 and negative 4. Now, if it helps you to organize your notes, what I'm going to do is I'm going to just sort of go back through and color code these. So I'll switch this maybe to green, keep that one blue, make this one orange, and switch this guy to red. Or, yeah, that's good. Okay, so that keeps my problem separate. So you have an exit ticket here where you have 3 problems. I want you to think about 1 and 2 are just normal with A, B, and C values. For this guy right here, A is 9. We have no X value, and B, so that means B is 0, and so we're left with C as negative 20. So watch for that when you plug it into your calculator. Okay, guys, hope you've had a good day. I'll see you on Monday.